we're back live. Remember, so we defined in general the average value of a function is between 2 points b and a is fb minus fa divided by b minus a. Most of you probably recognize that as slope of a line, right? Or a slope between 2 points, anyway. One of the homework problems was suppose f of t is cotangent t. Find the average rate of change between t equals 3 and t equals 1. To some degree, this is just formulaic. So this is going to be f of 3 minus f of 1 divided by 3 minus 1. 3 minus 1 is just 2. I'll write that as 2. So this is going to be cotangent 3 minus cotangent 1 divided by 2. So far, that's what we have. We may wish to simplify this. Undoubtedly, you're going to have to. And what I would suggest that you do, and remember, we're in radians right now. We're not in degrees. So what is this? This is the cosine, and this is cotangent, yeah. This is cosine 3 over sine 3 minus cosine 1 over sine 1. These are in radians divided by 2. Okay, so this is some number. You can either punch in the 3. You can do this in one chunk. There's another way you can do that. This is the same as 1 over tangent 3 minus 1 over tangent 1. This is divided by 2. You can punch this into your calculator. This is all there was into that. Tangent of 1 is what? This is pi over 4. It would be good if you knew that, but it's okay if you don't. And y, incidentally, so why is that? Remember, tangent is the slope. Here's the line, y equals x, right? So when this is, whatever this is, when this is 1 and this is 1, the tangent is going to be 1, well, whatever this degree is. Well, y equals x splits the first quadrant equally into 45 degrees, so it's 45 degrees. Let us do some more homework problems. Also, for me personally, this would have been a fine answer. A lot of professors would have wanted you to crunch the numbers. Make sure you get a feel for what your professor really wants. I tend to be much more about form and making sure you understand the concepts than worrying about numbers so much, but somebody with more of a physics inclination, especially an experimentalist, would definitely want some numbers. Okay, problem, just like when you're going to have to do it. It says simplify cosine t sine t times, what do we got? Cosecant t secant t. Secant t plus secant t, I should say. Okay, so anytime you do something like this, change it into sines and cosines to figure out what it is. In this case, so this is going to be cosine t sine t times cosecant t is 1 over sine t. Secant t is 1 over cosine t. This distributes, hits here, hits here. When it hits here, the sines are going to cancel. There will be cosine left. When it hits here, the cosines are going to cancel. There will be sine left. Piece of cake. How about something slightly uglier? Yes, how about it? Another homework problem, which is why I'm going to do it. No reason for you to have to do all the ugly ones yourself. Okay, remember, some important identities to remember are, of course, sine squared x plus cosine squared x is equal to 1. This is very important. Also, remember we had tangent squared x plus 1 is equal to secant squared x. I would like to introduce another one, and that is cotangent squared x plus 1 equals cosecant squared x. In calculus, these show up quite a bit. And hopefully you'll remember how I did this one, but once you see me do this, you'll remember this. Let's put this in its regular form. This is cosine x over sine x squared. That's just what cotangent squared is by definition, plus 1. This is the same, actually I'll bring it up a little higher. this is the same as cosine squared x over sine squared x plus 1. 1 is really 1 divided by 1. I'm going to get a common denominator in sine squared. Now I can add across the top. We have cosine squared x plus sine squared x over sine squared x. However, cosine squared plus sine squared is just like sine squared plus cosine squared. This is 1 over sine squared x. This is 1 over sine x squared. These are just the same things. I'm utilizing notation and manipulation. This is cosecant x squared. And once again, remember, cosecant x squared means literally cosecant x times cosecant x. It's very important to recognize that in general, sine squared x does not equal sine x squared. This really should be a notation like that if it does show up. Hopefully it will. Usually the books are pretty good about that. I probably have time for one more. Let's see what tangent squared minus cotangent squared is. And so this is what we're going to look at. Tangent squared x minus cotangent squared x. So they want us to simplify that. And right away, we could do something like this, but what the heck. We'll start from scratch. So I think the first thing I'm going to do is, remember, this has this form. This is a squared minus b squared, which is a minus b times a plus b. I don't know if this is going to help me, but this is an obvious thing to do. Here a will be tangent and b will be cotangent. So this is tangent x minus cotangent x times tangent x plus cotangent x. Now I'm going to turn them into what they are. That may have been a better idea in the first place. Who knows? This is sine x over cosine x minus cosine x over sine x times sine x over cosine x plus cosine x over sine x. Before I go any further, I'm going to clean these up. I'm going to multiply across the tops like this, and then across the bottoms, and this is going to give us the common denominators we need, sorry. So this, I need the common denominator of sine times cosine, so this side sine on top, sine on bottom, this will be sine squared x. This side will be cosine, cosine, this will be minus cosine squared x times cosine x, sine x. I guess I'll write it as that. I was going to write it as sine x, cosine x, it doesn't matter. So that's just this bit. Similarly, I want cosine and sine on the bottom, so this one has to be cosine, cosine, this one's sine, sine, so this is sine squared x plus cosine squared x over cosine x sine x. Fortunately, I know that sine squared x plus cosine squared x is 1, so this is going to be the same as sine squared x minus cosine squared x over cosine x sine x times 1 over cosine x sine x. That's because sine squared plus cosine squared is 1. The bottoms just multiply. This becomes sine squared x minus cosine squared x over cosine squared x sine squared x. Here's a problem. It's not a terrible problem to worry about, but are we done? Can we make this any more simple? And it's not actually clear. So what do you got to do? You got to keep fiddling. I didn't even read the directions. They just said simplify.